Aditi, we can start now. Probably people will join whenever they come in.
Okay. Yeah. Hi everyone. Hope you're all doing good. Sorry, 1 second. Okay, I'm gonna share my screen.
ಹೇಳಕ್ಕಂಗೆ ಹೇಳೋಕೆ ಶುರು ಆಯ್ತು ಅಂತ ಹೇಳಿ ಇನ್ನೊಂದ್ಸಲ ಹೇಳು she is already there ಅಂತ.
And can we just mute everyone? Okay. All right. So hi everyone. This is the 3rd class for the Python workshop. So I just wanted to start by continuing from where we left off and talking about the next sort of concept that's really important in Python called dictionaries. So dictionaries are similar to real-life dictionaries. In Python, they're similar to real-life dictionaries. In a real-life dictionary, you have an index of words, and for each of them, a definition. So we have cat, and then the definition for a cat, a furry animal or pet. And so in Python, the word cat would be called a key, and the definition is a value. And so this is usually called a key-value pair, and it's denoted, and I'll show you how it's denoted in a little bit. But yeah, the values aren't numbered. They don't have any specific order, and neither does the key. You can add, remove, and modify values in a dictionary. And to think of an example, another example, we can think of a telephone book. So you have someone's name, that's the, if you guys know what telephone books are, someone's name, that's the key, and then the value is their phone number. And so one interesting rule that persists in dictionaries also is that keys have to be unique, but values can repeat. So for example, let's say we have an address book. There's only one of me and there's only one Bharti Patil, but both of us live at the same address. That's allowed. And here the name is the key and the address is the value. Sorry. Okay, so let's talk about how we declare dictionaries and how we use them in Python. So this is one example. We have this dict equals, so we use these curly brackets when we want to declare a dictionary. And then this is how we do that key value pair. So this is what I mean. Brand in this case is a key and Ford is a value. So the brand of car is Ford, the model of the car is Mustang, the year of the car is 1964. So that's how we declare dictionaries in Python. And there are many methods that you can use to access it. For example, you can access the items by referring to the key name in square brackets. There's a function called get, and you can also change the value. So let's go and practice some. So let's say we have this dict. So like I said in Python, you never have to declare a type. You don't have to say dictionary or anything like that. When you give the proper syntax, Python will know. So technically you can do it on one line, but let's do it on multiple lines so it's clear and it's pretty. So first we have a model, so the model of the car, and then we have a colon, and we put the type of car. Now let's say we want to have the year of the make, let's say it's like 2020. So now when I print this dict, oh, oops, did I do something? Oh yeah, I forgot commas. It'll print out in this form. So the reason also why Yeah, so this is the form in which dictionaries print out. You can kind of think of it as a list, but like each category has a key value pair. So it's like a pair, and you can't separate these two from each other. Let's say you just wanted to know the model of a car. So we would use these square brackets, and we would say model. And in doing so, it'll tell us the model of the car. Let's say another way we can do this is by saying get. Get is a function that's really helpful in Python. A lot of different data types have get and other similar functions. I'm pretty sure lists have something similar too, where you can get a certain value. So let's say get model. So it does the same thing. If we did year, it would give us 2020. So that's basically covering these two. You can also change, you can also change the value of a specific item by referring to its key name. So let's say I wanted to change the year to 1984. So the way we would do this is, it's similar to the way we would change integer. An integer, if we had an integer like 4, we would just say, now we would just say x is 5, and that changes it, right? So in this case, sorry, did someone say something? Okay. In this case, we would use these square brackets to access what's at year, and we set it equal to 1984. Now when we print the dictionary, you'll see that it updates the year. See? So it's really simple. You just have to know like what key you want to change, what key you need to use to change the value. And next I'll talk about how you can also access values or keys. So we talked about loops as well. You can loop through a dictionary using a for loop. When you loop through it simply, it'll give you the keys. So for example, let's take this out. And if we just said, this is a for loop, if you guys remember. So a for loop, basically X or element, whatever you want to call it, basically goes through each individual element in the dictionary. And if we said print element, it would print out the keys that are in the dictionary. If we had, let's add some, if we had color is red, what other ones can I add? That's good for now. Wait, model year, brand. Oh. Okay. So now if I do that, it'll print out all these keys. Let's say you wanted the value, like you don't want to see brand, model, year, color. You want to know what the brand, what the model, what the year, what the color of the car is. The way we would do that is just access the key, the value, the same way we did when we try to reset it, the element. So this will go through each key and print out the value that's associated with it. So now we get Ford, Mustang, 2020, and red. Awesome. You can also use a values method. So this is a built-in method for dictionaries. Built-in methods basically means they're already pre-written for you and you don't need to do any work, like the get function. So you can use the values method to return the values too. So instead of this, we would write dot values, And the reason why it's empty is because it just accesses itself, so it doesn't need anything inside it. And then you would print element, and it does the same thing. Cool. Okay, and then finally, oops. Present it. Is someone not muted? I'm just hearing some background noise. Okay, I muted them. If you want to add a item, then you would use a new index key and value to it. I think we already showed that. But let me show you again in a different context. This is so annoying. Sorry. Okay. So let's say we didn't have color here and we want to add color. We would say this dict color equals red. And now we can add both the key and the value at once without having to do anything. So that's pretty cool. Now we have it here. So that's another easy way of adding. And then finally, we have the pop method, which is another built-in method that removes the item at a specific key name. So like this dict.pop model would remove the model from the dictionary. And I'll show that, but I just wanted to finally say that dictionaries can also contain dictionaries within them, kind of like how we saw nested loops and nested lists. We can also have nested dictionaries. So this is an example. Here we have someone's family, and so the first key is child 1, and child 1 again has a dictionary in it with the name of the child and the year that they were born. And then you close that inner dictionary and then make a new key for the outer dictionary with the second child and the third child. So that's why you have to, it's very important to have the correct brackets and commas separating each thing, because this is sort of a key, and then this inner dictionary becomes like a value, whereas inside it's its own key and value. So let's just look at that, as well as there's got to be an easier way of exiting, as well as the pop. Oh, oops. So let's say we wanted a pop model. We would just say model after pop. And also a cool thing about Replit is a lot of its built-in functions tell you what they are. So like here it says pop, remove specified key, and return corresponding value. So that's what pop does. It removes it and also tells you what it, oh wait. So yeah, now we have the dictionary without the model in it. And then let's say we wanted to do a nested dictionary using cars. So let's say we have, let me cut this just to make it easier so I don't have to paste again. So let's say we have car 1, and then inside this smaller dictionary, we want to list all the properties of this car. So let's say that's what we already had. It's a Ford, it's a Mustang, and the year is 2020. Now, and I'll put this on another line to make it clear, now we have a car 2. And in car 2, we have to make an inner dictionary where we say the brand. Let's say it's a Mercedes. Let's say the model, I don't know what the models are. I'm just gonna make Benz. And let's say the year is 2016. So now we have 2 cars that are inside this dictionary with their own dictionaries inside describing more about them. So this is really helpful if you want to do if you want to do projects in Python that have a lot of data, a lot of organization. It's really useful. Anything with mapping, coordinates, things like that. So I have to print it. Print this. So we see here, it shows us still in that curly brackets type form, car 1 has all these following properties, and then car 2 has all these following properties. Okay, so a quick quiz. Use the get method to print the value of the model key of the car dictionary. So what would go inside the print here to get the model key? The value of the model key, sorry. So Mustang.
Mustang. Mustang.
So how would we access the value Mustang? Using get. So we use get. We also use the square brackets. How would you write that? You can write in the chat, or you can try to explain it to me. No one has any guesses?
Car get model.
Yeah. So if we want to use get, we have to signal that we want from the model. So we put that inside. So that's one way. Another way that we can get it is by using these oh, oops, that doesn't work because there's 2 values in it. Another way we can do it is by using these square brackets. And as you just saw, it gets a little complicated when you have multiple nested dictionaries in doing this. But we won't go into that because it's a little above our level. So yeah, let's continue. Next slide. Okay, so I think I touched upon this, but there's a lot more to be said, and I think the logic for this is really important if you guys choose to do final projects. So I wanted to talk about if, elif, else statements. So these statements are used when there is decision making required. Basically, if statements only happen if a certain condition is satisfied. So the way they're written in Python is if, and then you have a test expression, and then a statement. So the program evaluates the test expression only if the test expression is true, not text. If it's false, then the statement is never executed. And this is also where indentation is super important, but a lot of editors will do that for you. Another thing to note is that non-zero values in Python are interpreted as true, none and 0 are interpreted as false. So this is basically like a logic diagram of that. So we have if, and then it asks a question, like maybe it asks, is Aditi 20 years old? Is that true or false? It's true, so then it'll print you're 20 years old. But if it was false, it wouldn't do anything. So we can practice that also with integers, with strings, anything. So let's say if let's have an integer, and it's called num, like number, equal to 3. Let's say if num is less than 5, print this number is less than 5. Let's make it a little more useful because this has to connect with the future slides that I'm going to say. So we'll say this is a positive number if it's greater than 0, right? An interesting thing then to understand is that if I close the indentations and then I say, put a print statement here and say, let's say this will always print. What happens here is num is checked to see if it's greater than 0, and if it is, it'll print this statement. However, I exited out of the if loop by indenting left. This will always print. So we see that here. If I had num was -1, now we just get this because -1 is not greater than 0. So it never enters this if loop. Oops, that's on. So that's how if statements work. Next, we have if-else statements. If-else statements evaluate a test expression and will execute the body of if only when the test condition is true. If the condition is false, the body of the else is executed. Indentation is once again really important here to separate it. So we can see that here, but more importantly, we see here. So let's say we ask, let's say we have a test expression. If it's false, then we go to the else statement and execute what's there. If it's true, we follow what's in the if. So modifying what we did with the if statement, let's say we have if, now we have else, and indentation important. Else's have to be lined up with the if that they're associated with. And else's cannot be present unless there's an if with it. So you can't just have like an else sitting around like that. Doesn't work. An else always comes after an if. So let's say if the number is greater than 0, then this is a positive number. But I kind of think it like otherwise, else this is a negative number. So now with num is -1, we get this is a negative number. And if I did 5, we have this is a positive number. And I think you're already seeing a problem. What if the number is 0? It just defaulted to this because it's not 0 isn't greater than 0, but 0 is not negative. So that's what we'll address in the next one, which is called Elif statements. So Elif is short for else if. It allows you to check for multiple expressions. If the condition for if is false, it'll check the Elif, and then if that's false, it moves on to the else. But you can have an infinite amount of Elif statements, like check this, then Elif this, then Elif this, so on. Yeah, so it can only have one else. An if block can only have one else block, but it can have multiple elifs. So one example then, this is the logic of it. So it tests the test expression of the if first. If that's true, it just does the if and you're done. But if it's false, it goes to the elif. And if it's true for what the elif requires, then it'll execute that. But if it's false, then it defaults to the else. So what that means for this is that after the if, we add an elif, and elifs also require a condition. Else's don't, but elifs and ifs do, because that's the whole point, right? You're asking for another expression. So if it's equal to 0, then we should print this is 0. So now when we have 0, it checks this. It says 0 is not greater than 0. Oops. Oh, that's another point. I mentioned this yesterday, and I will go over it as well in a little bit. But in loops and like expressions, if you ever want to see if something is equal, like if num is equal to 0, you have to use double equal signs. It's called a Boolean operator, and I'll explain that in a little bit. But yeah, so you ask, is num equal to 0? And if it is, then that's what happens. And it works for other test cases. I won't spend too much time on that. And then once again, you can have nested if, elif, else loops. So any number of these statements can be nested in within another. You just have to be sure the indentation. So like here, they're asking a number from the user. We'll also talk about input in a little bit. If the number is greater than or equal to 0, let's say they gave the number 5. So that's true. Then it asks if the number is equal to 0, and it'll print 0. That's not true, so it defaults to the else, and it prints positive number. And you can run through the different scenarios. They can get confusing, but I know that in some like interactive stories and things like that that you might choose to build, they can be, they're sometimes used. It's basically all logic. And let's say we had -1. So if, let's say they put in the number -1, so it'll check this condition. It'll say if -1 is greater than or equal to 0, that's not true. It defaults to this bigger else. So that's why indentation matters. You can always see where one thing will jump to another. Then to talk about those things that that we just saw a little bit, and also a few of these we haven't seen. There are a bunch of operators: arithmetic, comparison, and Boolean. Boolean basically just means logic, true or false, in its simplest form. If you know any computer science, you know that 1 traditionally means true and 0 means false. And if you know what binary is, it's kind of the same thing. So those are the building blocks for computers, and that's why they're so important. But they're also used in logic in a lot of ways, and we covered this a little bit when we did and. But I just wanted to talk about some of the other ones that we haven't talked about. For example, we have a divide left operand in Python, but we also have floor division. That's because Python is interesting. Oops. And I'll do this over here just because I don't want to array, like it doesn't really need code. So when we do 10 divided by 5, Python actually prints it as a float. That's what this division means. That's because in some other languages, when you do that, like let's say you did 10 divided by 4, in some computer science languages, that would just round to the nearest integer. But Python gives it to you as a float automatically, making it easier, right? But let's say you did want an integer, you would just use double. That means floor. So it sends it to the nearest, the lowest nearest integer. So it rounds down, basically. Another important one is exponents. So exponents are using double stars, not like the caret. And then finally, another really important one is called modulus. So this gives you the remainder of the division of the left operand by the right. So like, for example, 10 divided by 5 goes in evenly, right? So it's just 2, but 10 divided by 4 doesn't go in evenly. So we can do 10, we call it mod 4, and it'll give you the remainder. That makes it look a little weird. Let's show 3. 10 divided by 3 is all that, right? But 10 mod 3 is 1, right? Because 3 times 3 is 9, and then 10 is 1 more than that, so that's the remainder. That's also used a lot in computer science and is helpful to know if you're doing anything where you need to know any remainders. All right, so a little quiz time on those. In Python, what is the value of the expression 100 divided by 25? Remember that Python, remember the operator we're using and how Python writes float numbers. Yeah, I got one answer. Does anyone want to say it or have any idea? Okay, well, the person, who chatted me was correct. It's 4.0, and that's because, so it's basically saying standard division in Python is always float, which is decimals. If you wanted just to get 4, you would use the double. And then to talk about Boolean operators, again, these and comparison operators, these are logic based. So it's used a lot in Python when you want to evaluate expressions. So we have and. This returns true if both operands are true. So for example, makes it so hard to exit. For example, we have x is true, y is false, z is true. Okay, so if we had x and y, this would give us false. True and false gives false because both have to be true. So if we did x and z, it would give true. You can also do this with numbers. You can say x is 1, y is 0, z is 1. If I do x and y, I get 0, right? But 0 in Python is essentially the same thing as false. And so, yeah, that's really important to know what 0 and 1 mean. For or, this is true if one of the operands is true. And since it's so annoying to go back and forth, I'm going to just go through this and then go back later. Not is true if the operand is false. So, for example, like let's say, so let's say x is true, then not x would be false. So it's the opposite. You're just like flipping it. These are truth tables. Just to clarify once again, like if you have something true and false, it'll give you false. Basically, the only time an and is true is when both of them are true. For or, it's a little more complicated. It's just it's one or the other has to be true, or both of them are true. And then for not, if A is true, then the opposite of A would be false. If A is false, not A is true. To see some more examples of this, let's use this example. So let's say we have num is 1 and num2 is 5. So let's say we say if, print 1 is equal to 5. So first let's just see that, right? Are they equal to each other? So that's false, right? Now let's say we wanted to use this logic then in if-else statements, because that's where this logic comes important. So I should have said num1. So if num1, let's say if num2 is greater than num1, then print this number is larger. And remember, if we want to include the variables, we would call by the name and then put a comma and then quotes. And so let's say we say num2 is larger than num1. And then we could do an Elif, num1 is greater than num2, print num1 is larger than num2, and else, so if num2 is not greater than num1 and num1 is not greater than num2, then they're equal. So I'll say equal. So this is where, So this is where logic comes important. Anytime you're using an if statement, anything in the parentheses after it has to be a logical expression, something that you're evaluating. So that's why this is so important. So in this case, we have 5 and 1, so we have 5 is greater than 1. Okay. So let's just go there. Okay. So what would the following code print to the console? This is just like pretty simple question, just to make sure you guys are following. So the way you can think about this is we have a string. I know we did with integers, but we have a string cat, and we're asking, is it not equal to dog? So that's true, right? So it would print true because they're not the same thing. If you said 1, that's not like really wrong because 1 means true, but because these are strings, the default is to use true rather than 0 or 1. If like, so I mean, even if you have 1 equal to 5, it would say false. If we say cat is not equal to dog, it'll say that's true. Yeah. So here's also miscellaneous concepts that are really helpful that I wanted to go over since, this is the 3rd class. So there's something called Python libraries. Just as I was saying that lists and dictionaries have built-in functions like get and values. These libraries are reusable chunks of code that you sometimes might want to include in your programs. So an example of this is a library called math. Math has a lot of operators like taking the square root of a number, a bunch of things like that, the average, things like that. So, and then another one is called random, and we'll use that. It saves time and energy, and you use it by calling import followed by the name of the library. So if you want to use math, you would write import math. Let's say you want the user to give you input. One way of doing this is by using the word raw input with this underscore, and then in quotes you would put in the question that you ask the user. So let's say enter your age, and then this will give you whatever they said without its type. So you typically use that when type doesn't matter, like usually like strings or something like that. However, sometimes we want the specific type because we're going to use it to add, to subtract, to divide. So we need to know what it is, right? So in that case, we would use, this usually applies to numbers. So we would put int in front of it, and then in parentheses, we would put input. And inside these parentheses, you would still ask that same question, like what is your age, and then close. This could be int, this could be float, it could be whatever type you need. Then we have break statements. This is just literally you write break, and it's when you want to exit out of a loop. Let's say, and we'll see an example of this in the number generator game that I'm going to practice. And finally, random numbers. Random numbers can be sometimes important to generate. Like, for example, I'm going to say later, like one of the games that you can make is a rock, paper, scissors type game. Oops. So sometimes you might need to generate like a number 1, 2, 3 just to see if you're rock, paper, scissors. So the way you do that is by writing random.randint and then a comma b. So it'll produce a random integer between a and b inclusive. So it also, there's one for floats also. So let's see this in a number generator game. So deleting all this. So again, just to like refresh a lot of things we did, hashtags are for comments. So in this game, we want to ask the user for a number, and then we're going to give them a certain amount of tries to guess the number that we've generated by using the random. And then we check to see if they're correct, or if they're wrong, we give them a hint whether to go guess higher or lower. So the first thing that we're going to start is we need random, right? We need to make a random number. So we're going to say import random. Next, I mean, we can, yeah. We're just going to introduce the game. Okay. Someone unmuted. Okay. Yeah, so from there, let's start by asking the user for a number. So we're going to, the way I'm going to do it is by putting print, enter a number from 1 to 10. Okay, that's our guessing range. Then we have to also keep track of how many guesses that they've made, right? Because let's say we want to cut them off after 5 guesses. So let's call this guesses and set it equal to 0 for now. Because they haven't made any guesses. So what we're going to want to do is, oh wait, did I think I also forgot. Oh, okay, yeah, I forgot, you first have to generate the random number. So the way we do that, like I said, is by saying number, and then we use random.randint. I like Replit a lot. As you see, it says it really helps you out when you're typing. The dot implies that you're using a function also. I don't know if I mentioned that. So let's say 1 through 10. So this is inclusive. So the number could be 1, 2, 3, 4, 5, 6, all the way up to 10. It generates it randomly. There's some like algorithm behind it, but you don't need to worry about it. So now we ask the user, let's just put this here as well. So we ask the user for a number. So the way we keep track of the user's guesses and when to know to finish the game is by using a while loop. So we say while the guesses are less than 5, and again, you can use this. So while the guesses are less than 5, then the user has to give us a number, right? So that's when we say int input. And this is what we're getting from the user. So let's say, okay. I'll call this chance and call this guess. Yeah, so guess is equal to the input that they gave from this print statement. and we set it to the integer value of what they entered. The reason why I separated it, for example, I could have had it here, enter a number from 1 to 10. It doesn't do a big difference, but as you'll see, like if I ran it this way, you'll see that it's a stylistic error more like, that just bugs me. But leaving it blank, it still understands that what's typed in the console is input. So that's cool. You don't need to put anything in it technically. So now we're gonna tap into the if-else statements that we were learning. So we have to see if this guess is the same thing as the number. So we would say if guess is equal, using the Boolean, is equal to number, then we're done, right? So we would print, congrats, you guessed the right number. And this is where break statements come. By putting break here, it exits out of the rest of the loop I'm going to write, and it's done. It'll stop executing. But let's say you don't get the right number. Let's say you guessed too low. So if the guess is less than the number that we want, then you would print your guess was too low, guess a higher number, right? And then if that's not, and then finally, if it's not lower, then it's got to be higher, right? So we would print your guess was too high, guess a lower number. So we handled all the cases using if-elif statements, and then another way we can avoid also using the break statement, like the break statement here, oh wait, actually we still need it. So the break statement here, what it does, to reiterate, is if the guess is correct, let's say the random number is 5 and we entered 5, if that happens, then it'll print the statement, and break basically takes you out. It doesn't do any of it. It doesn't even consider any of this. The last thing that we have to do is increase what the chances, right? Because after each input, we have to increase the tally for how many guesses they've made. So the way we do this, and we talked about it, is doing plus equals 1. And I do it at the end because I don't know when it'll go into one of these loops. So now let's try running it. Yeah, so number generator, enter a number 1 through 10. Let's say we say 3. Oh, wow, lucky me. Let's say it was 6. Your guess was too low. Guess a higher number. Congrats. Now let's just show you how it can end if you choose it, like just to see how it runs. How am I keep guessing the right number? If I just guess 5 every time, it just terminates there. Let's say we want to give them a message saying they lost. We would exit out of the while loop, because the only time this will happen is if they didn't guess the right number, and say you lost. Okay, so what I taught you guys earlier is about if statements applies too. So once it exits out of this while loop, it will print this no matter what. Like let's say I did 3, 3, 3, 3, 3. You lost. But let's say I guessed the right number, it still said you lost, because I'm printing it here no matter what. The way we get it to print only when you actually lost is by saying if chance is equal to 5, then we print you lost. And that's the correct way. Now, Oops. Now we can check for when it's really. Now we don't get this U lost. Okay, I hope that makes sense. I just want to, and I will include the code so that you guys can take a look at that. And then, so just to talk about this briefly, what I thought would be really great for next week's class is I can touch on a few final things, and then you guys can try creating your own projects to share with the class. I can text people to see who would be willing to do so. I would really love if you guys would be willing to do that. And I'll see the interest that you guys have to offer over the next week. I've also included some ideas. One of them is rock, paper, scissors. You use random number generating to have the user play against the computer. And you can have it go on as long as you want. You can do Mad Libs generator using input and then printing out different data types. You can create your own Python calculator using functions. You can also create a storytelling game using if-else statements. So like if you ask the user, like, do you want to go left or right? And then if left, then you're in a fairy tale wonderland. And if you go right, you're in a dungeon. Like you can have fun storytelling games like that that come to an end. I'll also be linking some sites that can help you guys do these projects. I don't have them on me right now, but I'll put them in the WhatsApp group and text it out individually as well. So yeah, that's all I had. Next week is last class, and it's just about on time. Does anyone have any questions about this or the number generator or anything else that I covered? No? No questions? Well, if not, then that's all from me. And yeah, like I said, I will follow up about links to any resources, and please let me know if you have any questions about the projects.
I think people are a little shy. That's it, Aditi. So probably just soaking in the whole class. So to next week will be the last class, right? You said? Mm-hmm. Okay. So do you see anybody like taking the whole stuff and making some project? Like, do you have any candidate whom we should be looking to create a certificate or anything? Maybe we can take it offline. We can talk offline.
Yeah, I have a few people actually. I'll just message or please message me because sometimes the names on here don't really line up to the names I have in people's, like, in my phone, you know what I mean? Like someone's name here is Intune iPad or OnePlus TA destination. So if you guys, before you leave, could just let me know who you are, then it'll be easier for me to at least reach out to those people, because there are some people that I think could qualify, and we can also take it offline as well, like you said.
Okay, cool. And on this platform, I'll also like to tell, like, Kcanva has their own website, and like Aditi or somebody else would like to help us in doing some development there, would love to have you guys there. So Aditi can take the names, and when you're collecting the information, check out, like, if anybody's interested, Aditi, forward them to Varun. We are planning to form a small group of youth who would be interested to do certain activities. It may be web development or an event organizing, or quite a lot of things are there for youth itself. So I would like to see the interest. If anybody's interested to be part of it, reach out to me, or in this platform, reach out to Aditi and she can reach out to us.
Yeah, that would be awesome. I'll reach out to you as well.
All right. Thanks, guys. If
Okay, thank you, everyone.
yeah, if nobody has any questions, then we would end this session here. Looks like no. Thanks
All
again.
right.
Once again.
Bye.
Okay.